Hello YouTube viewers, welcome to my channel Science or Technology. In today's show, Science Thursday, we're gonna talk about LoRa. So let's dive right into it. Well, what the heck is this LoRa? This is basically long range. So why it's such an important thing? Well, it's a new wireless communication protocol. Generally, protocol requires a unique hardware and software combination, because again, you can't just take your old 2.5 gigahertz Wi-Fi router and make it 5 gigahertz. So same way, you need dedicated hardware and software. So generally, a new protocol generally means a independent system. Now, the selling point, why the hell anybody wants to even focus on this? Because we have radio, we have Bluetooth, which is very low power, we have Wi-Fi, which is very high bandwidth. What the hell is the unique selling point of this puppy? Is basically it's low power. So power requirement is almost Bluetooth low energy level. However, the interesting part, this puppy is long range. How long range? Well, in kilometers. Basically, in average normal Joshmo kind of scenario, you can easily get upwards of 1 to 5 kilometer. 1 kilometer is like almost guaranteed. Like if you have any sort of mast or even a good antenna, 1 kilometer done. So this puppy is measured in kilometers, and if you do directional antenna, you can easily reach up to 20 kilometers. So this is, in terms of range wise, it's on a whole different level. Now, many times we have this kind of technology in the past, but generally they are either a ludicrously big, heavy, expensive. This time it's completely different. It's super tiny, super small, including the antenna. So you can get something that is this small and you still have all the benefits of that. Or sometimes you may want to have a huge antenna, you can do that. So that's the whole selling point of this: long range and low power. So how the heck this magic works, where it has a low power requirement and idiotically long range? Well, radio communications. Radio communication, you have to understand, the higher the frequency, the poorer the transmission happens. Basically, if you take 2.5 gigahertz, and you must have experienced it, is that you can receive the signal quite far off. Like especially if you are living in a multi-story building, you have let's say 2.5 gigahertz in the ground floor, it will work in the second or third floor. But if you have 5 gigahertz, while the speed would be more awesome, almost twice or 3 times depending on your ISP, you are still limited only to one floor. The moment you go to second floor, it's like nope. Same happens with 5G also. 5G is quite 100% useless, simply because it requires line of sight. So line of sight requirement, you're gonna get awesome speed, but the moment you have go around the corner, put your hand in front of your mobile phone or something like that, it blocks the signal. So higher the frequency, lower the range. Basically, it's simple mathematics, you cannot bypass this. So what these people do, basically they went into sub gigahertz. If 2.5 gigahertz is good, going in megahertz would be even better. That's the whole selling point of this puppy works in sub gigahertz radio frequency band. So generally they have multiple slots. So that slot is like 433 megahertz, 868 megahertz, 915 megahertz. Now the reason why they have these three bands is simply because based on region, India is different, Asia is different. Yes, I don't ask me why. India, Asia, USA, Europe, all these are different. So they have their unique basically quote unquote ID, if you can say that. And the architecture of this puppy is basically you're gonna have a node which is gonna be your sensor data remote end, basically, and all those remote end, you can have multiple remote end. Let's say you have a giant farm that you are trying to manage, you could have multiple humidity sensor, multiple temperature sensor, multiple let's say wind sensor, things of that nature. You can have all that data would be streamed into a central point, and central point would be classified as gateway. Now this gateway would be connected to the internet. So if you have to collect data, like many people are doing this for forest management, where they have multiple data points, and all that, if they use let's say even a mobile network, if it is there, they use that. Problem would be like, let's say giving one SIM card is not expensive, but if you have to pay a subscription for let's say 20-30 sensors, you will like whoa. So the idea is you're gonna have multiple centers, and it's like centralized network, and you only need to digitize, so to say, networkize the gateway. That's the core architecture. You're gonna have multiple sensors, all of them is gonna connect to the gateway would be connected to the main network, aka World Wide Web. If you want it, like, you can limit it inside only. It's not that it's not gonna work, it's up to you. And you can connect this to any API. So you can have you are abroad somewhere, and you can still receive your notification on your mobile phone if you need that. So that's the whole idea of it. Reducing the frequency below gigahertz allows them ludicrously long range, and transmission ability also. So even in rain and things of that nature, it will still have a tangibly good range. So this is the whole workings of it. You took the frequency and you lower it down. Now, inevitably, whenever we are talking about radio systems, we end up with law. Now, law, you have to understand this. The radio spectrum is governed like ludicrously well. It's like every aspect, every spectrum is sliced up, governed by individual bodies, and they're like, okay, in this kind of spectrum, you have to do this, and that. Now, you may think it's a government overreach, but reality is we have to have this, because you can understand it this way. We have multiple service provider. Let's say you have Verizon, Airtel, Geo, whatever have you. You have multiple service provider. All of them are using 4G. Your mobile phone is 4G. How the heck all of them are working? Because there is rules and regulation to maintain it. So that rules and regulations allows smooth operation. So it's not just like government overreach. It's we have to have this basically. Now there are many open standards like 2.5 gigahertz. That's why you can use it in your normal home network setup, 5 gigahertz. But problem is those are already in this, and not to mention because of the high frequency, they are not for long range. So inherently that's like nope. But on top of that, you might be like, okay, let's say I went down in the frequency, but I amped the power up. Could you transmit very long range? Yes, that's how old radio system used to work. That could literally go across Atlantic, so to say. So power is also limited. There is a reason for that, because you may think, okay, I have a frequency, basically an antenna that is transmitting in, let's say, 500 megahertz. It should not affect 3 gigahertz or 1.5 gigahertz or 2.5 gigahertz. It will not. No, that will never work. Like if you have something that intense, like kilowatts of radio power, it's gonna have harmonics or some other hoo-ha that you have to have PhD to understand with other radio spectrum. And you have to understand this is also done for prevention. Basically, imagine it this way: like there are 5 mobile towers, and one of them is low one. They are not getting good coverage. What if they bumped up their power to ludicrous level? All the others one will end up losing the signal. So for this reason, there is a serious limitation on transmission power. On top of that, there is a limitation on duty cycle. Basically, how long you can keep the transmission on. Basically, you have to slice it up in such a way that other communication can also take place in the same frequency band. So there is a lot of rules and regulation in this. Now, not all frequency is open everywhere. So you can take one, let's say, radio communication equipment from America. It's like open, legal, everything is awesome. You could find out that if you bring that equipment in India, you are violating the law. Now, again, for a general single person user, it's not like the police is just gonna come at your door because they are that jobless. But if you want to sell your equipment, you have to be mindful of this. So in India, if you want to use basically LoRa, you have to be inside 865 megahertz to 867 megahertz, and that's the Indian system. So basically, you can just buy that. That's why LoRa equipments will have like slots mentioned in behind them. You can pay attention to it. It's technically software defined radio, but if the oscillator crystals and antennas are fine tuned for that spectrum, it will work much better. So that's why law is so important. Now, why the heck every Tom, Dick and Harry wanted me to cover this? Well, reality is Internet of Things is real now. It's no longer just an idea that was somebody might do it, because again, the moment it starts to affect farming, it affects food on your table. So it's precious, important, and very serious. And not to mention, farming is just one, of course, very important one, but it's just one. There are other places where people are doing asset management, like let's say managing your parking lot. You can understand that they are very serious business nowadays. You could have a scenario where you are managing a natural reserve and you need multiple, sometimes even hundreds of basically remote sensors managing a giant, hundreds of hectare kind of land kind of scenario. You need this kind of equipment. So it's no longer just like niche and all that. No, it is crossed that threshold. At this point in time, it's real. It's gonna here to stay, so to say. So many devices needs long range. Flat out, you need long range. So in those sort of scenarios, you cannot rely on Wi-Fi or some other radio system. Nothing is designed to work for this well, for this long range, for this low power. So this is awesome, and that low power requirement is very critical, because you can have one 18650 cell, which is lithium ion, which is mass produced. You can easily buy that. Heck, that's how Tesla built its first battery car and all that jazz. So that one cell, rechargeable cell, can power one equipment for almost a year if done correctly, while it's transmitting data daily or sometimes multiple times a day. So that's more than good enough. Let's say you are a farmer and you're you have hundreds of hectares. The one key metric that people want to keep an eye on is basically humidity. If you can fine tune the humidity, basically not too much, not too little, you're good, you're golden. Basically fertilizer and all that, we got that at this point in time. But humidity, that's tricky, because again, if wind blows too much, your humidity will go down. If wind is not blowing, your humidity might go up, but you have to track it properly. So to do that, you need to monitor humidity. Now, humidity is one factor. Even if let's say you have a sensor, it's just a 8-bit value, that value would be transmitted across that. So that's one 8-bit value, and you're like, okay, I'm gonna have sensor, let's say every 100 meters, and you have a grid pattern. All of them only have to send one tuk every 5 minutes. You don't need 24/7 data bandwidth real time, because again, it's not gonna change. And not to mention, because it's using lower frequency, it inherently is very slow. And because of the laws and regulations and all that jazz, you would be really lucky if you can get even 1 kilobits per second. Yeah, it's very low. So it's, do not expect this real time. I'm gonna one earthworm crawled out of its hole, I'm gonna spot that. Yeah, that's not happening. So based even with this kind of limitation, but the fact that it's battery power, the fact that it's ludicrously long range, ranges are measured in kilometer in city. In open areas with directional antenna, 20 to 30 kilometers is easily feasible. So people are going YOLO over it, and there is a very good reason for that. So what we can expect in the future? Well, reality is it's opening a new way of communication, because in recent time people have realized that all our communications have been spied on, like flat out. Question is not who, whether it's being spied on. Question is who is spying. Is it your government, or is it a private corporation, or Mark Zuckerberg? So at this point in time, people want a way of communication that is not spyable, so to say, at least this easily. The reality of that, the only way to achieve that is not to utilize someone else's infrastructure. If you are using Verizon's infrastructure, by default you gave your permission to Verizon. It's like, bro, do whatever you want to do with my data, because I'm using your infrastructure. Or same goes with every other Tom, Dick and Harry scenario. So what if you remove the middleman? Let's say you directly remove the infrastructure, so to say. So this allows this, because this is such an open standard, such an open source system. People have successfully figured out that limitation, that all of these nodes have to communicate to gateway. They made it into a mesh network. Basically, one will communicate to other nodes, not to the gateway, but to the nodes. Benefit of that, you can, let's say in a big city, let's say like a New York or Mumbai or Bangalore, you can have like a few thousand of this, let's say 5 or 6,000, and all of them communicate to each other. All of them will get their ID and password and all that jazz, and they can have a messaging service which nobody can spy on. And not to mention, this system was designed from day one with encryption built into it, because again, they were targeting the Internet of Things marks, the company that actually started this whole process. So it's already built in there. And because there is no central database, there is no infrastructure to spy on or to tap. Ta-da! So that ability, this person built a very interesting one, doomsday communicator. So it's quite amazing, this kind of thing for modern day, it's kind of useful, not to mention. And the open source standard, that means even more things can come out of it in future. We don't know. It's just look at VLC, how it was 5 years ago versus how it is now. So, and Linux, same thing goes. So open source means it has a lot of room to grow. The more people will use it, the more better the community will get, the better outcome we're gonna get. So that is there. Another individual around 15 years old, or 15 or 16-year-old, took this concept, took it to a whole different level. It's like he built a satellite. The system is Fossa satellite 1. I don't think it worked, because the satellites are not CubeSat, they are smaller than CubeSat. CubeSat is 10 centimeter cube. This puppy is 5 centimeter cube. Now he used the same system with a different radio antenna, obviously, but the core architecture was the same. It was sent in space. The idea is, he's building a network. Once done properly, you're gonna have, basically, let's say you are doing forest monitoring or remote management system. All the data needs to go to internet in some place, some way or some another way. So idea would be, this will be act as a relay station in orbit. So you're gonna have, again, cheap off the shore part, that is $20 or less than $100. Let's just go with that, less than $100. You can have a your weather station, your humidity sensor, or all that, and it's gonna wait. All the data will be collected, stored, and it's gonna wait for the satellite to go again low Earth orbit. So it's not like geostationary, it's not gonna be there 24/7. So it's gonna wait. The moment satellite crosses it, it dumps the data. The satellite will store it temporarily, and then it's gonna dump it into the next gateway the moment it comes across. Tada! You have satellite coverage for your basically Internet of Things device. That's a whole different level. So future is quite bright, and not to mention, inherently somebody is daring to do this open source wise. So you can see the codes, see the hardware and all that jazz, and the service will also be free. Now, right now it's not working, but there is another company that is also doing the same kind of thing, but they are charging for the service. Again, acceptable bargain, and not to mention, you can control the system the way you want it to. It's just that they are charging satellite as a relay station. So all these things, the mesh topology, the actual satellite network, the open source standard, the fact that it allows a new way of communication, it's mind-boggling, in terms of probability and possibilities are possible right now. So it's quite amazing what people have done. So this was my presentation on LoRa. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.